Hey, welcome back. So the first of the sorting algorithms that we're going to take a look at is called bubble sort. So bubble sort is not all that efficient. It's not that commonly used. There is one use case we'll discuss where it does excel, but generally we're not learning it because it's going to be, it's not going to rock your world. You're not going to be implementing it all the time. Although it is a very good problem, it's a fun one if you know how to do it, and there's some optimizations we can make. So it's a good thing to talk about, and it also helps us understand why other algorithms improve upon it. So don't skip it, please. Okay, now that I've made it sound terrible, let's talk about why it's called bubble sort. So the idea is that if we have an array and we're sorting from smallest to greatest, so in ascending numeric order, the larger values will bubble to the top one at a time. So what I'm going to introduce now is something that we haven't seen up until now, I think. It's called visual, well, I actually don't know how, I use this all the time in my classes. Visual algo. It's a combination of visual and algo for algorithm. So I like visual go, but the way it's highlighted, it makes me question my pronunciation. So what it is a really cool interactive tool in the browser that lets you step through sorting algorithms, among other things. I'm currently looking at bubble sort, and you can see that we have some data. If you open this up, by the way, your data set will look different. I input these numbers specifically. I didn't want to have a massive data set that took me like 10 minutes to step through. So we have 7 elements ranging from 10 up to 37. Okay, so this is our array. This is the first item and this is the last item. The way that bubble sort works is that as we loop through each item, we compare it to the next item, the one in front of it. And we check, is this one larger than what we're comparing it to? And if it is, we swap. So swapping is really important to bubble sort. It's how it works. You basically swap if something is larger and then you compare it to the next one. Is it larger? Swap again. Compare it to the next one. So let's just step through that. So 29 and 10, we swap because 29 is larger. 29 and 14, that's the next comparison. We swap. Now we compare 29 and 30. This time we don't swap. So now we have 30 and 37. 30 is not larger than 37, so once again, we don't swap. Now we compare 37 and 14, and now we do swap. Now we're on to 37 and 18. Compare the two, and we swap. So that was our first pass all the way through the array. And what happened is that the largest value bubbled to the top. I've also heard this as sinking sort, where the largest values sink to the end, to the bottom. I think that's a little more pessimistic. Bubble, it's so much happier. Who doesn't like bubbles? So now we repeat the process. I won't make you watch every single step of this, but we start again at the beginning. So we compare 10 and 14. We don't swap. We compare 14 and 29. Again, we don't swap. We compare 29 and 30. We don't swap. Now we compare 30 and 14, and we do. Next, we compare 30 and 18. Once again, we swap. So now we have the last two values cemented in place, right? 30 and 37, those are sorted. So we're building this list as the values bubble up to the top or to the end, the largest values. We know that those last two items are now sorted. Those don't need to change. And on we go very quickly. Go through this, we swap, 29 bubbles to the top, and eventually we end up with this sorted array. So on the slides, I have a simple walkthrough of one of those iterations. So if this is our array, we swap. If we compare 5 and 3, we swap. So 5 moves up. Next, we compare 5 and 4, we swap again. Next, 5 and 1, we swap again. And finally, we compare 5 and 2, and we swap because 5 is the largest element in the array and it ends up at the end. So that's for one single iteration. Then all we need to do is repeat that over and over. And you could start by repeating once for every item in the array, but remember that as we go through, the amount of items we need to sort decreases because we started out with 5 elements that were unsorted. Now we have 4 unsorted elements and 1 solidified sorted element. So that means that we have fewer elements to sort as we go through. So our loops can reflect that. But first, let's talk about swapping. Since that's such a crucial part, we have to swap. How does that work? Well, in JavaScript, there's a couple ways of swapping. I have two listed here. This is honestly my preference. It's not the newer way of doing it, but this is how the tried and true way of swapping values. I think it's kind of more legible, easier to understand. You don't even have to make a separate function to do this, of course, but here what we have is an array and then the two indices that we want to swap. And we set up a temp variable to store one of them. And then, so if that's the first one, index of 1, we set up a temp variable and save that to that value. Then we change what was in array of index 1 to now be what's in array of index 2. And then lastly, we use that temp variable to update array of index 2. So that's how I like to do it, but there's also in ES 2015 this syntax for doing it, which I don't know, I just don't think it's very readable personally. But the syntax basically is take the whatever's in index 1 and swap it with index 2, take what's in index 2, swap it with index 1. And this works, and it is a single line. So for those of you who are file size queens, who care about how short your files are, you can use this. I'll probably use both, but it helps to define a function called swap because then our bubble sort code becomes even shorter. The actual logic really is just about the comparisons in the loops, and then we can just call swap. But you don't have to define a separate function. If you want to implement it, which I highly recommend you give it a shot, here are some of the steps. Start looping. So define a function, I didn't add that in, called bubble sort. It takes an array, and you can assume it's all numbers. Start looping with a variable called I at the end of the array towards the beginning. And we'll discuss exactly why, but it has to do with the fact that we're shrinking down the amount of space that we're sorting. Then an inner loop inside of that outer loop with a variable called j from the beginning until I minus 1. So I is referring to the first loop. So we have a nested loop that is depending on the first loop, I minus 1. And then we just compare array of j, so that's going to be our individual, if I went back here, let's say we're comparing, if j is 0, we're going to compare it to array of j plus 1, which is the next item. So whatever j is, we're going to compare the item ahead of it. So j and j plus 1. Okay? So if array j is greater than array of j plus 1, that means you need to swap. And you can swap however you'd like using whichever version that I showed you. And then at the end, just return the sorted array after the loops are done. So give it a shot if you'd like, and in the next video, we'll have an implementation.